Hello everyone, I welcome you all in the C programming and data structures lecture. This is set 1 of stacks gate problems. In this presentation, we will see some gate problems on stacks. So without any further delay, let's get started. Here is the question available in front of you. The following postfix expression with single digit operands is evaluated using a stack. So we have a postfix expression. As we can see this over here, this is the postfix expression. The following postfix expression with single digit operands. You can see all of the operands over here. These are single digit operands. And actually this expression is evaluated using stack. We have to evaluate this expression with the help of a stack. Note that this operator is the exponentiation operator. Okay, this is called a power operator. You may call this exponentiation operator. The top two elements of the stack after the first star is evaluated are what? We have to find the top two elements of the stack after the first star is evaluated. These are all the options available in front of you, and this question has been asked in GATE CS 2007. I would encourage you to pause the video for a while and try to answer this question on your own. I hope you're done. Okay, let's move on to the solution. First, let's try to understand this problem very carefully. Here we are available with the postfix expression and we have to evaluate this expression. And we have to evaluate this expression up to this point. Understand this. This is given in the question. Okay? And this expression must be evaluated with the help of stack. Why is that so? Why can't we just simply go ahead and evaluate this expression? Because the question says that we need the top two elements of the stack after the first star is evaluated. That is why it is important to consider a stack in order to see the top two elements of the stack after the first star is evaluated. Okay. So let's see how to solve these type of problems. Always remember the following golden rule of thumb. I would like to give the golden rule of thumb in order to evaluate a postfix expression, and here is the rule. The expression will be scanned from left to right. It is important that our expression must be scanned from left to right. All the operands will be pushed onto the stack. We must push all the operands onto the stack. Okay, so our stack will be an operand stack, right? And as soon as we will encounter an operator, we will apply it to the two topmost elements of the stack. Simple. So if we have operands, we'll push them onto the stack. If we have operators, we'll apply it to the top two elements of the stack. This is the golden rule of thumb we must always remember for postfix evaluation. Okay. Now here is the postfix expression and we are available with this stack, right? Now according to the question, we have to find the top two elements of the stack after the first star is evaluated. This means after the first multiplication operator is evaluated, we have to find the top two elements of the stack. This is the first star operator, that is the multiplication operator. We have to see the status of the stack after the evaluation of this multiplication operator. Okay. Let's scan the symbols of this expression one by one from left to right. First, we have encountered this symbol. We can see this is an operand. So we will simply push this operand onto the stack. According to the golden rule of thumb, please remember that rule. Okay. After this, we have this operand. We'll again push this onto the stack. Then we have this operand. We'll push this onto the stack. You can see the current status of the stack. The top two elements are 3 and 2, right? Now the next symbol is an operator and not an operand, right? Now we have to apply this operator to the top two elements of the stack. Currently these are the top two elements of the stack. First we will pop this element out of the stack and then this element out of the stack, right? Here order does matter. Now the most important question is, shall we perform 3 to the power 2 or 2 to the power 3? This is the main question, right? We have to apply this operator to these two operands. Now the main question is order. We have to understand the order of evaluation. Whether we will perform 2 to the power 3 or 3 to the power 2. This is the question of concern. Always remember this, that the topmost element of the stack will be treated as the second operand. And the second topmost element of the stack will always be treated as the first operand. Okay. So here, this is the first operand and this is the second operand, and we can perform this particular operation between these two operands, where this is the first operand and this is the second operand. So 2 to the power 3 will be performed and not 3 to the power 2. Okay. So what is 2 to the power 3? It is 8. Now we will push this 8 onto the stack. Simple. I hope this idea is clear to you. Now we have a division operator. This means we have to perform division. Let's pop the top two elements of the stack. First, this element will be popped and this element will be popped. Second topmost element becomes the first operand and topmost element becomes the second operand. And we know 8 divided by 8 is 1. Now we will push this element onto the stack. Fine. Up to now everything is clear. Next symbol is an operand, right? You can see this. We'll push this onto the stack. The next symbol is an operand. Again, we have encountered an operand, value 3. We'll push this onto the stack. Then we have an operator, multiplication operator. This is the first multiplication operator, right? According to the question, we have to find the top two elements of the stack after the first star is evaluated. Let's first evaluate this symbol. First, we will pop these two elements out of the stack, right? So 3 is popped out of the stack and 2 is also popped. We know that 2 will be the first operand and 3 will be the second operand. We'll perform the multiplication of these two operands. This turns out to be 6, and then finally we will push this symbol onto the stack, the result onto the stack. Now you can see this, that these are the two topmost elements of the stack, right? 6 and 1. So the answer to the gate problem is 6, 1. Okay? Up to now, I think everything is clear to you, but let's evaluate this whole expression and let's see what is the final result. Okay? So let's do that. After star, we have a plus operator, which means again we have to perform the operation between the two operands. Let's pop these two operands out of the stack, 6 and 1. We'll perform the addition of these two operands. 1 plus 6 gives 7. We'll then push this result onto the stack. Now the next step is, of course, to scan the next symbol. Next symbol is 5. We'll push this symbol onto the stack. Then we'll push this symbol onto the stack. And then after this we have a star operator, which means multiplication. We'll perform the multiplication of these two operands, that is 5 into 1. 5 into 1 is 5. We'll push this symbol onto the stack. Now we have minus operator. This means we will perform subtraction between these two operands. This will be 7 minus 5. Isn't that so? 7 minus 5 gives 2. Now we will push this operand onto the stack. And it is clear that the result of this expression is 2. After evaluating the whole expression, we'll get this as a result. It might be possible that in the question they will ask you to evaluate the whole expression and find the result. Here we know the answer to this question. The answer to the gate problem is 6, 1. So it is clear that option A is the correct option for this question. Fine. Now let's see question number 2. Assume that the operators plus, minus, multiply are left associative. Assume that these operators are left associative and this exponentiation operator is right associative. Okay. This is very important assumption according to this question. We have to assume that these operators are left associative and this power operator, this exponentiation operator is right associative. The order of precedence from highest to lowest. It is given to us what is the order of precedence. What is the priority of all the operators? It is available to us from highest to lowest. This means power operator has the highest priority and subtraction operator has the lowest priority. You can see this over here. We have power, we have multiplication, we have addition and we have subtraction. We already know this, that power operator has the highest precedence and subtraction and addition operators are having the lowest priority, right? We know this already. The postfix expression corresponding to the infix expression, that is a plus b multiplied by c minus d to the power e to the power f, is what? These are all the options available in front of you, and this question has been asked in GATE CS 2004. I would encourage you to pause the video for a while and try to answer this question on your own. I hope you're done. Okay, let's move on to the solution. We have assumed that these are all the operators we are available with, and these operators are left associative. These three operators are left associative. There are total 4 operators where plus, minus, multiply are left associative and power, this exponentiation operator, is right associative. This is very important. Now we have this infix expression and we have to convert this to its equivalent postfix expression, right? So let's do this. We are available with this infix expression. Let's evaluate this expression. First, we can see this that in this expression we have plus, we have multiply, we have minus, and we have a power operator, that is exponentiation operator. Now, which operator will be evaluated first is a question of concern. We know that power has the highest priority. Even according to the question, power is having the highest priority. Therefore, this operator will be evaluated first. But you can see this that there are two operators, two power operators are available in front of us. Now which expression will be evaluated first is a question of concern. Whether we should evaluate d to the power e first or e to the power f first. That's the main question, right? And we already know this that if the operators have the same priority, they have the same precedence, then associativity comes into picture. Here we know that these two operators have same precedence. And we also know that exponentiation operator is right associative. Therefore, this expression will be evaluated first. Power operator or exponentiation operator has the highest precedence and the associativity of this operator is right to left. Therefore, this expression will be evaluated first, that is e to the power f. This becomes ef power. Got it? Now, the next step is to evaluate this whole expression. This becomes def power. I hope it is clear. This was the step d to the power ef power. You can treat this as the first operand and this as the second operand. Now, obviously, this power will move towards right. This becomes def power. Got it? After this, we have the multiplication operator and we know this that multiplication operator has the second highest priority in the above expression. Therefore, this expression will be evaluated next. This is b into c. This becomes bc into, right? After this, we have a plus bc cross, which we can treat as one operand. So, this is a plus bc cross minus def power. We have a plus operator, we have a minus operator, we know they have same precedence, but the associativity is left to right. Got it? Plus and minus has the same precedence, also they are left associative. Therefore, we will evaluate this first, a plus bc multiplication. That is, this becomes a bc multiply plus. And finally, we will evaluate this whole expression. And this minus will go towards right. This becomes a bc into plus def power minus. So, it is clear that option A is the correct option. Okay. Please understand this, even the order of precedence is given over here. That is power, multiplication, plus and minus. You can say this that the plus is actually having greater precedence than minus, right? In any case, plus will be evaluated first, right? This means this addition will be evaluated first and then the subtraction. Even though if you won't consider this that the precedence of these two operators are same. In both the cases, even if the precedence of these two operators are same or they are not same, still this plus operator will be evaluated first, right? In both the cases, option A is the correct option, right? So I hope this question is clear to you, but it might be possible that they will change this question a little bit. Okay, it might be possible that they will make this exponentiation operator left associative. What to do in that case? What if the power operator is left associative? In that case, the whole expression will be evaluated again. Of course, we have to evaluate this once again. Here in this case, this expression will be evaluated first. This becomes de power and then this whole expression will be evaluated next. This becomes de power f power, right? And then we will evaluate this expression. This becomes bc into, and then we have a plus bc into, which becomes a bc into plus. Then we have this whole expression a bc into plus minus de power f power. This minus will go towards right. This becomes a bc into plus de power f power minus. This is the whole expression so obtained. Now you can see this. In this case, option B is the correct option. It might be possible that you will accidentally mark this as the correct answer, right? But as you can see this, that the power operator is right associative. Therefore, option A is the correct option and not option B. Okay. If power is left associative, then option B is the correct option. I hope the whole idea is clear and these two questions are also clear to you.